Let us learn today voltage generator and motor. According to Oersted law, when conductor carries current, it produces magnetic field around it. The converse of this is proved by Faraday's, and according to the Faraday's law, when conductor cuts magnetic lines of flux, an EMF is induced. I am repeating the sentence: when conductor cuts magnetic lines of flux, an EMF is induced. So here you are seeing these are magnets. Here there are coils, and these coils are connected to LEDs, light emitting diodes. So here you are seeing these are the conductors. These conductors are connected to these LEDs. These 5 coils are connected to 1, 2, 3, 4, 5 coils. To cut magnetic lines of flux, motion is required. Without motion, it is not possible to produce electricity. Magnetic lines of flux you can emanate from these magnets, neodymium magnets, these magnets. Now I am keeping it here. On the opposite side is optional. If it is required, then you can connect. So when you rotate, you are seeing that magnetic field also rotating. So magnetic lines of flux are cut by these 5 wires, and hence according to this Faraday's law, electricity is induced. Let us see once again. Here you are seeing induced EMF is proportional to the number of turns, N means number of turns of the coil, then phi flux density means how magnet is strong, and the rate of cutting. So if you rotate with a high speed, then intensity will increase. See, so here you can see no battery is connected here for the glowing of this LED. Only this rotation and magnetic field is inducing EMF, and that EMF are glowing these 5 LEDs. Now this LED is also glowing. After this, let us see same principle. Here the coil is placed here, and this is the magnetic field. So when you cuts, see here, when you cuts means rotate magnetic field, EMF is induced in the coil and EMF is generated, and that EMF is able to glow these LED. Inside this there is a coil. The description about these coils you can see somewhere else in this video or in the description box. Then here one more circuit. When I rotate it, this LED is glowing. Here you are seeing inner surface as magnetic field, this one, and here are the coils. Right? So when I connect when conductor cuts, magnetic lines of flux and EMF is induced. When conductor cuts, magnetic lines of flux and EMF is induced. If rotation speed is high, induced EMF is high. And here also you can see when I rotate this wheel, this wheel is connected to this motor. So this motor is acting as a generator. When you rotate its shaft, it will produce electricity. You are seeing that this LED is glowing. If this continuously rotates, then this LED will also continuously glow. So in this way you can understand the working principle of voltage generator. Now let us see the principle of motor. So principle of motor is when a conductor is placed in a magnetic field, it experiences a force. When a current carrying conductor is placed in a magnetic field, it experiences So principle of motor is when a current carrying conductor is placed in a magnetic field or near a magnetic field, it experiences a force. When a current carrying conductor is placed in a magnetic field, it experiences a force. Now see here. This is the magnetic field. This is a coil, and when you switch on, current starts flowing through this coil. So when current carrying conductor is placed near or in magnetic field, it experiences a force. So let us switch on this circuit. You are seeing this required initial torque. So once sufficient torque is given, then you are seeing it starts continuously rotate. So here you are seeing that this acting as a motor. When current is given to the circuit, this coil, the coil produces a magnetic field. Then in this neodymium magnet also there is magnetic field. Both magnetic field interact, and you know, like pole attracts, unlike like poles repel, and unlike pole attracts. So when I stop this, let's try once again. Since the resistance of this coil is very small, if this bulb is not connected in series, then short circuit will occur. That's why bulb is connected in series. So as soon as you switch off this switch, motor stops rotating. Here you can connect fan. Now today let's stop here. The remaining part we will see in next video. Goodbye.